Hey guys, welcome to CodeGrad. Today in this session, we'll cover the topic data structure and we'll cover the important topics like the list, tuple, dictionaries, set, string, tags, queues, dequeues, and we'll see also the implementation part where we'll get a better understanding of this concept. So let's start. So data structures in Python, they are used for organizing data for easy use, and data structures are fundamental concept for organizing, managing, and storing data. And choosing the right data structure can significantly impact a program efficiency and reliability. So in Python, data structures help us to store, organize, and manage data. They are most essential for writing efficient programs. And if you define the data structure, it is a way to store and organize data in memory, and in the different structures are used for basically different tasks. Now, when we start with the list, so list store and order sequence of items which can be of mixed data type. So this is an ordered data type and it stores sequence of items. Now it can be mixed data type. Suppose in a list we can store a string value, integer value, or float value. So we say that it is a mixed data type and they are mutable. So in mutable means we can add, update, delete, meaning their content can be changed after creation, that is add, remove, and modify. So a list can store multiple items in a single variable and you can add, remove, or change items. So that is the list one. Then moving on with tuples. One more thing for list, we denote it by square bracket, and lists are basically the most used data type as we can store multiple data types and we can also we are able to add, update, and delete this element. So they are used most often. So next is tuple, which is ordered and unchangeable. So tuples are similar to lists as they store an ordered sequence of items. And now these tuples and lists both are ordered sequence of items. Remember that. But the difference is that tuples are immutable. So we cannot add, update, delete these items available in the tuple, meaning their content cannot be changed once created. So a tuple is like a list, but you can't change its content, and is useful when data should not be modified. Okay. So if you want to do not make any changes to your original data and you want to remain as it is, the original one. So at that point of time, you can use tuples because tuples are as fast as compared to the list. Now next is the dictionary, which is the key value pair. And in dictionary, dictionary stores data as an unordered collection of key values and key values pair. So previously we have seen the list and tuple where they were ordered one, but this is an unordered collection of key value pair, and they provide fast lookup, insertions, and division based on a unique key. So they are mutable basically. We can add, update, and delete, and we can do multiple insertions also and deletions based on a unique key. We can summarize it as the dictionary stores data in pair. Okay, there are key value pairs, and they are great for looking up data quickly, and they are introduced by curly bracket starting with key. Suppose I mention a key as name, a string, and after semicolon, suppose I mention current as also a string. So name is the key and current is the value. We can also insert multiple key values pairs in dictionary. Now next is set. Now set, as we have discussed in the previous session also, they are the unordered and unique one. So set stores an unordered collection of distinct unique elements. So if we mention a set and having multiple values like 1 comma 2 comma 3 comma 4 comma 5, and if I again introduce one there, it was previously there in the set, so it will be removed because we have only unique elements in the set. So whenever we have to remove duplicate, at that point of time we can introduce set, and they are useful for membership testing, removing duplicates and performing mathematical set operation. So we can summarize the set as it is a collection of unique items, no duplicate. Okay, and useful for membership test. Now next is the string. We have seen this also earlier. So anything between a single quote, a double quote, or triple quote can be considered as a string. And strings are used to represent textual data. Whenever we want to use text in our Python, so we generally enclose it between the single quotes, double quotes, or triple quotes. So they are used to represent textual data and are an immutable sequence of Unicode characters. So they are immutable. We cannot add, update, or delete. And they support various operations like slicing, concatenation, and searching for substring. So these are the operations supported by the string. And we can also define string as a series of characters. Okay, so a string is a series of characters used to store text. And we have seen that string support indexing, slicing, and looping too. That is the string. Next, we have the stack. That is the last in and first out. Okay. So stack is an abstract data type that serves as a collection of elements with uh, LI, LIFO, which is the last in and first out ordering. And common operations include push, that is add to top, and pop, that is remove from top, often implemented using list. Now we can say that a stack is like a pile of plates. Okay, the last one you put is the first to come out, and it uses undo actions or backtracking also. So that is the stack one. Moving on, we have the queue, which is the first in, first out. So a queue is an abstract data type where elements are added at one end, that is the rear, and removed from the other, which is the front. The this FIFO, which is first in, first out behavior, is often implemented using list or the collection, and collections.dq object for efficiency. So a queue works like a line. First in line is served first, and it is used in task scheduling or like printing job. So we basically have to import it. So from collections we have to import DQ, then we have to call the DQ function, and then we can append. Next is the DQ, which is the double-ended queue. Okay, a DQ from the collection module support efficient appends and pop from both ends of the sequence, and they can be used as highly optimized stacks or queues or for other scenarios requiring fast and operation. So DQ allows adding, removing from both ends. Okay. So first of all, we have seen the stack and queues where we have the stack, we have the last in, first out. So what will be the last one? That would be the first one to get out. And in queues, we have seen basically it is an list, first in and first out. So we can imagine as a line. So first in the line is served first. So that is the queue. And but in the case of the DQ, we have the what we can say DQ allows adding and removing from both ends, and it is more flexible than stack or queue. So DQ is basically the double-ended queue. These are the different data structures which can be used for our personal task, and according to the task, we can use the particular data structure. Now we'll summarize it. First of all, we'll see the list one. So in case of the list, we have they are ordered, they can be they are changeable basically, we can add, update or delete, and in this case we can say they can store items in a sequence. Next is tuple, it is ordered, yes, we cannot it is not changeable, so we cannot add, update or delete. And use case is when we have the fixed data, so at that point of time we can use the tuple. Then we have the dictionaries, which is not ordered and it is changeable, we can add, update, delete. And unique values are like key and value pair, and we have the lookup by keys. Next is the set where it is not ordered and it is changeable. It has unique element or the distinct element, and it removes basically duplicate. So wherever we have to remove the duplicate values, we can use set. Next is the string. It is ordered. Yes, it is not changeable, right? We cannot add, update or delete. It is not unique, and for storing the textual data, we use the string. Next is the fact, which is order, yes, and it is changeable also, and it is used for undo feature most of all, and it is basically not having any unique values there, or unique to remove any duplicate. So for that purpose, we cannot use that. Next, we have the queue. It is ordered, yes. It is changeable, yes. We can add, update or delete. Unique, we have no. And for the use case, we say that we use for task scheduling. And the last is the DQ, where it is an order, yes. It is changeable, yes. For unique, no. And use case, we can say that it is efficient for two-sided operation. So these are the data structures, and we should choose the right structure based on your task. And understanding data structures makes your code faster and smarter, and you can mix structures together for advanced use cases. Now let's move towards the implementation part and get a better understanding of the data structure topic.